Uh, so guys, if you can write in the questions tab. Yeah, so okay, I think everyone is able to see my screen. So just for my sake, let me open up the competition that we are going to sort of discuss today. So the competition is essentially Porto Seguro Safe Driver Prediction. So what I'm going to do, guys, is I'm going to run you down a brief introduction of what the problem statement was, why is it relevant, and why, as a data scientist, as well as a company, people want to crack this particular problem. Uh, then I'm going to run you through the basic steps of machine learning, how you typically attempt this problem, that is from EDA to feature engineering, and then of course to modeling and then hypertuning, etc. Post that, I'm also going to touch upon a particular aspect which I think many of you would be interested in is after you build the model, how do you integrate the particular solution that you have built in the environment or in the systems of the existing organization. I think this is a topic that is very relevant in today's time because machine learning and artificial intelligence in itself has been validated to provide benefit to the organization. Now the race has all transitioned from who can get the solution integrated into the organization with the lowest lead time as much as possible. With this, I think there are a couple of providers that have enabled smoother transition of data science solutions to production, and they are namely cloud providers. So I'm pretty sure you must have heard about AWS, which is the Amazon Web Services, which is again a cloud provider and gives a variety of cloud solutions, as well as GCP, which is the Google cloud platform. I am going to demonstrate how you can productionize a particular model on the AWS platform side of things. But the same thing can be replicated in GCP as well, because it's essentially the same thing. So let us just get started with it. One second. Yeah. So yeah, I think everyone can see my screen. So let's just get a move on. So this is Proto Seguro. This competition was essentially about Proto Seguro. Now, a bit about Proto Seguro is that they are an insurance, specifically a car insurance company based out of Brazil, and I think they are one of the largest auto and home insurance companies in Brazil. Now, how typically home and auto insurance works is that as soon as you want to apply for an insurance, you have to provide some specific details about yourself as well as the car you want to insure. So you would specify your personal details such as, your location, how many people are there, how many people are going to drive that car, how old are you, whether you have a valid driver license, where do you stay, what is your educational background. And from all of this, the companies can also get financial data, which is your credit score. Now, credit score is something that in India is also now become very vital, which tells these insurance companies how responsible of a person are you. Now, if you have a low credit score, that would clearly mean that you are financially negligent, which will automatically also translate into you also being irresponsible in terms of owning property or driving a car. Then you also have some car specific information, for example, the model number of the car, the make of the car, and then other mechanical related questions. For example, it is 4 engine, 2 engine, whether the car has airbags, it does not have airbags, etc. Now, this is a typical data set that will be provided to you when a person is making a claim. Now, as a company, what you want to do is you want to incentivize those people who you know are less likely to claim because their premium is essentially going to act as a profit for you, and you want to decentivize or charge more money to those particular people who you know are rash or unsafe drivers and are likely to claim over the next year's duration. So what people want to know is when a particular person is coming to you to buy a policy, is that particular person likely going to claim, or is he going to commit an accident next year, or is he a safe driver? Because based on that fact, you can either give him a discount or you can either charge him a premium. Because even if you charge, so that is the thing in organization is profitability is very subjective. Now, you might think that selling more policies at one particular stage is profitable, but if your number of claims at the same time increases, it's actually going to cost you more, even though you wrote out more policies to start with. So, for any insurance player, predicting whether a person is going to claim next year or not is a very big challenge. And this was again a similar exercise that Porto Seguro wanted us as Kagglers or data scientists to solve. So the evaluation metric, I'm pretty sure a lot of you know, is going to be Gini. Normalized Gini is essentially the same sort of metric as AUC. I am assuming that every one of you knows what under the curve is. Under the curve is essentially a validation technique which is used to validate whether a particular model is performing good on the test set or not. Now, what's going to happen is I'm going to go through a lot of technical jargon as I go along and solve this particular notebook. So I'll be constantly monitoring the chats. Uh, I will sort of constantly monitor the chats and try to see if there are any burning questions that you want me to solve. And as we go through this particular demo, we'll try to answer as much as we can. All right. So, as I was saying, AUC is another metric that is very similar to Gini coefficient. And why do we want to use AUC and Gini coefficient instead of accuracy will become more clear when we transition towards the first part of this exercise, which is to get a sense of how does the data look like. All right. So let's start with that. Perfect. So, guys, what I want to start off by showing to you is a very basic EDA Jupyter notebook that I had used when I was first doing the particular problem. Now, the best part of Kaggle is that if you go into the notebook section, you get a host of these notebooks where people have done brilliant EDAs with brilliant visualizations and have also given you a summary of all the findings that they have found. This particular notebook was in R. I generally prefer to use Python, so I have downloaded this notebook that is Interactive Porto Insights, and I am going to talk you through this particular notebook and also show what is the relevance of the EDA that was done and how it helped me as a Kagler uh, understand the data and then apply different techniques accordingly, right? So let's start off with Porto Seguro Insights. Now, he has given just a basic example of what is the introduction, what are we trying to solve, which I essentially have given out as well. Now, there are main three themes of this notebook. First is the data quality check, which is what you as a Kagler or even as a Novens data scientist, many time you are provided a data set. This is the first thing that you try to solve, which is to see what is the data looking like and what are the limitations or anomalies of this particular data set. Then we just go to a very vanilla or basic baseline model where we want to off the bat understand how many features in this particular data set are important and how we can create some custom feature engineering scripts or metrics and get along with our objective. Towards the end, in my Kaggle, you will find if I just run you through my GitHub account, 1 second. Yeah. So in my GitHub account, you will find a module named Python scripts. These are entirely running scripts where you can just use this script and run each of these scripts to get the output. I have also gotten a main.py, which I will explain is essentially the modelized and classified code that I have. So this modelized and classified code is essentially the code that goes into production. When you start off with a Jupyter notebook, but once you have created a model which has been signed off by all of the relevant stakeholders, you want to build your code in such a way that it is easily scalable, editable, and you can put into production. So that is why you will find the main.py, which I will run in a later step. You will be able to see how you can go about productionizing and modularizing your code, and what are the benefits that you will get if you try to productionize and modularize your code. Apart from that, I have also added both the EDA tutorial, EDA Python notebooks that we're going to use. So all the codes that we're going to talk about in today's session is going to be available to you online, right? So getting into it, you can clearly see that these are essentially all of the Python packages that we typically use: pandas, numpys, matplotlib. Over here, we are going to use another package for EDA, for visualization, which is known as which is known as Plotly. And I'm going to go towards the reason why I use Plotly. Because the visualizations are much more interactive and intuitive and more industry quality. This is in fact the same package that I actually use is actually a practice of using in a current organization as well. So I'll go through those as well. So starting off, initially, it is one of the same thing where what you do is you try to read what the data set is, right? So now if I look at the data set off the bat, I can make out a couple of things. One thing is that the entire data set is anonymized. Now, this is typically what is going to happen in many of the organizations as well, because with the advent of GDPR and other data protection pipelines, a lot of the organizations share their data with data scientists in an encrypted format. But they have given us some identifiers by which we can see what are the different columns. So where you see I and D, that clearly shows that the target is our target variable. ID is the identifier column. Target variable is essentially the variable we want to predict, which tells whether the person has claimed in the next year or not. Similarly, if you go and you start seeing the bin column, bin is essentially the binary column, and cat essentially stands for category column, and similarly indicator value also stands for indicator column, right? So binary are binary columns which have 0 1 values. Bin are essentially continuous variables which have been binned, so they can have any value from 0 to 10. Categorical are again categorical variables, but these categories are actually in the form of numbers. And then apart from that, you also have these reg variables or regional variables, which are continuous in nature, so they represent a continuous distribution. Now I can clearly see that these are individual. I and D stands for individual, so these are all individual level characteristics. And then you have PS reg, which is essentially region level characteristics. And then you have car, which essentially tell you that these are car level characteristics, which are telling you about what the car is. And then over here you also have some continuous variables related to car, and then you have some calculation fields. So from a very high level point of view, we can clearly make out that this data set has individual level characteristics. This data has car level characteristics, region level characteristic, and some calculations which we are not aware of. And it has three sets of data points. One One is a binary variable where it will be a binary indicator. It could be any variable such as, does it have does the car have safety airbags? Have you bought a policy with us before? Have you done any claim before? And there are other characteristics such as region, where is the particular person located, which car is it, which make is it, which model is it, etc. Right? Then we want to see what is the size of the data. So you can clearly see that this is a big data set which has around 600,000, or in Indian terms 6 lakh rows, and around 60 columns, right? Now you want to do some data quality checks to see whether there are any null values or not. Now over here you can clearly see that there are no null values, but this is something that you cannot rely on accurately, because a lot of the times what happens is people simply replace all the num values with a string value like -1 or -99. So you need to be pretty careful if you spot those sort of values. Now in our case, just look at this PS car 03 category. You can clearly see that there is a negative category, and similarly there's a negative category in 05 variable as well. So what we can clearly off the bat see that in this data set, there are negative values, but these negative values are substituted for -1. Now, from a practical standpoint, this is very relevant even when you're getting data set from within the organization, because a lot of the time people have created tables and the data owners have left. So you do not know what is exactly the data dictionary of that particular table. So what you need to do is you need to do a manual scan by doing train, tail, or looking at all the individual categories of a particular column to understand whether there are missing values in the data set or not, right? So here we can see that our null values returns false, but however, this does not mean that we do not have null values. -1 is what we see is actually what null values stand for in our data set. So because we know that Python as well as R, for that both these languages are able to handle missing values properly, so we replace the -1 in the data set by nan, right? Now there is this package which is missing number, which has been created by a Kaggle, which lets you visualize the amount of missing values within a particular data set. So let us run this. Now, because this data set is large, you will clearly see that it is taking a lot of time to run different outputs, right? So from here you can clearly see that off the bat of it, most of my data set is clean, that is, it has no null values. But if I look at some of the variables, for example, PS region 03, PS car 03 cat, PS car 05 cat, car 07 category, car 14 category, these clearly have a lot of null values in them. So you can clearly see that the white represents a lot of null values. Another thing to note is that this visualization only gives you the first 40 categories. So what you want to do is you also want to plot for the rest of the categories. So yeah, so I can see that for the rest of the categories, you do not really see a lot of null values. Even if they are of a very minute amount. So here you can see that there are 7, but you can also see that there are other values, and these are the primary 7 null values which we are able to observe, right? So PS indicator 5, reg 5, card 5. So we need to treat this specially. So this is one of the first basic steps that you do whenever you get a data set. That is, you first of all see how many missing values are there, visualize those missing values, and then jot down all of those target variables which need to be imputed or treated before you move on to the modeling step, right? Now, after this, the second step that is very important in any modeling exercise is to understand how the target variable is behaving. So what we want to do is we want to do a simple bar plot of the target variable. Now over here, what I have used is I have used something which is known as matplotlib. Now the reason I use is because of this interactive design. So here I can clearly see that majority of my data is 0, whereas 573,000 data points are 0, and only 21.69 thousand records are the ones which claimed last year. So which is true, because in insurance you sell policies and you do not expect a lot of claims to come through, only small claims to come through, right? So now if I talk about percentage terms, I want to get this data in terms of percentages, right? So let me get the percentage as well. Yeah. So here is a very interesting statistics that pops up. It's also evident here, but 96% of our data set is 0 and only 3.6% of our data set is actually 1. So over here we are dealing with a classic case of data imbalance. Because my zeros and ones are not properly defined, there is a data imbalance problem. Now, whenever there is a data imbalance problem, you will realize that you cannot use precision, recall, and accuracy as a validation metric. Let me give you an example why that is. Now, let's say you have 10,000, let's say instead of 500,000 records, you only had 10,000 records, right? Now, out of those 10,000 records, just assume, could you, let me just see if there are any questions before I move on. Uh, The audio is sounding garbled. Guys, is the audio coming correctly? I think it's coming correctly at my end, but you guys can have a check. Yeah. So again, as I was saying, what you cannot use accurately over here is you cannot use accuracy, precision, and recall. The reason is because all of these metrics are based on decision boundaries, right? I'll give you an example. Let's say, uh, yeah, let's say what happens is that you have a data set which has 10,000 records, right? And out of those 10,000 records, you have a binary classification problem like the one we have over here, which is to predict whether a person is going to claim or not. Let's say we have a binary classification problem, and out of those 10,000 records, only 100 records are the ones where actually the one category occurs. Or let's say in our case, out of those 10,000 records, only 100 records are such which claim, right? Now people tell you to come up with a machine learning model. You as a lazy data scientist do not do anything. What you do is you simply classify every problem or every record that you get as no, he is not going to claim. So I'll give you 5 seconds to think about what will be the accuracy of your model. The accuracy of your model is going to be 99.9%, because if you look at it, you only got 100 claims wrong and you got 99,900 claims correct. So that is why you cannot use accuracy, because accuracy is based on a decision boundary. Similarly, with precision and recall, if you keep on changing your precision boundary or the decision boundary, either your precision will increase or your recall will increase. You can manipulate both of these based on the decision boundary you choose. So that is why you want to use a metric which does not use accuracy as well as precision boundary in place, or decision boundary in place. So one of the best methods that you can use for this sort of problem is AUC, which is area under the curve. You can also use Gini, where the simple formula is Gini is equal to twice of AUC minus 1. Why do you use AUC? Because AUC uses sensitivity and specificity, and it plots all of the decision boundaries that are possible and then brings the curve. So clearly, this is how you need to use to choose your validation metrics whenever you get a binary classification problem, right? Someone wrote why we cannot use F1 score. I would just like to remind you that what is exactly the F1 score? F1 score is the harmonic mean of recall and precision. And recall and precision are both driven by the decision boundaries. So that is why a more better, see, none of these metrics are wrong per se, but a more robust or a less biased metric is definitely AUC or Gini. And that is why if you go into this competition, they have asked you to evaluate the Gini coefficient, and they have also given you the Gini value. And what you'll see is they are not using a hard cutoff. They are asking you to give them the raw predictions. That is the raw probabilities that you're going to get, right? Yeah, you could also use log loss. Log loss is also a perfectly justifiable metric. You could use confusion metrics as well. But how Kaggle works is you need a single metric. So for using a single metric, you cannot use a confusion matrix because confusion matrix will give you 4 values: the type 1 error, the type 2 errors, the number of true positives, and the number of true negatives, right? So let's move on. So that is why you can see that you need to do target variable inspection to get these values across, right? Now what you want to know is train d-type values. You want to see how and what is the relationship of these values. So you can see that 49 of them are integers and 10 of them are float. All of the floats by default will be continuous variables, and all of the integers will by default either be categorical variables or will be binary variables. Now, because we do not have a proper data dictionary in place, it might be the case that we are substituting one or the other in this particular algorithm, but this is what we have to take with a pinch of salt, right? So moving on. Now, before we move on, so now one of the best things that I want to see is what is the correlation of different data points within the data set. Now, in order to do that, one of the best things or the best solutions that I have is to do a Pearson's correlation plot. And when plotting between different variables, the best technique that I can use is a heat map. So again, there is a package which is known as Seaborn. You can use Seaborn to sort of get a heat map. And if you use the right valuations, you can clearly see how the data is correlated with one another. Off the bat, you can clearly see that there is very little correlation between each variable, barring some of the columns. So I can clearly see that there is a positive, or I can say a little positive correlation between region 1, region 3, 2 and 3, card 12, 13, and card 13 and 15, right? So from this, I can clearly see that there is some of the values are correlated, but a lot of majority of the values are not correlated. So from here, I can clearly build an intuition saying that, you know what, most of my data in this is garbage. I need to only keep some of the relevant data. I do not need to use all of the data when I'm going to do my modeling exercise, right? So this is one of the clear intuitions that I can get from this particular graph. Similarly, after doing this, we also want to see the correlation of the integer features, right? So again, what I'm going to do is I'm going to do a very simple plot again, and I'm also going to use the integer values as well. Here as well, I can clearly see that there are some values which have a negative correlation, some which have a positive correlation. I mean, the diagonal is always going to be positive because the correlation is within itself. What am I interested in is these boundaries and these darker, relatively darker colors and images. So I can clearly see that some of the categorical variables are also correlated with one another. So that means that I have gotten a relatively decent data set where I can see that there are no huge anomalies in place, and there are some variables which I can use to gather some predictive power, right? So there is another thing that because this is a binary classification problem, you have something which is known as a mutual information plot, which we can use to see the predictive power of individual variables. Now, this is very closely correlated with the correlation coefficient. It's just that it rescales it on a factor of 0 to 1 and uses the nearest neighbor algorithm. Now, this is optional. If you want, you can use it. If you don't want, it's your choice if you do not want to use it, right? Bear in mind, because we have a very big data set, so it takes a lot of time to sort of run this particular algorithm. So if I let it run, it's going to take a couple of seconds for it to run. So let's just see the output of this particular column. So before, if you look at before we were trying to do, before we were trying to see the correlation within itself, right? We were trying to see the correlation within the particular categories. This is trying to plot the correlation with respect to the target variable. So we want to see that out of these these 10 floating variables, which value has the most predictive power. Now, remember, what we have tried to now do is we are descending right from EDA into feature selection, right? Yeah. Could you please explain how to read the charts for correlation? Okay, perfect. So let's go on the top. Now, on the top, you can clearly see that the correlation value is already printed inside. So 0.64 means that the correlation coefficient is 0.064, and over here the correlation coefficient is 0.047. So both of these actually tell that this is a really good, it's not a really good correlation, but there is some positive correlation because the correlation coefficient varies between -1 to 1, right? Over here, I know this is a dense plot, but this is how you can read the correlation. Because we are using pie plot, wherever there is a negative, wherever there is a color change, hover over that, and the z value will give you the negative correlation coefficient value. So over here you can see z is equal to -0.4164, which is again in the negative space, is less. So that means that there is a inverse relation. By inverse relation, what do I mean is that as one value increases, the other decreases, or a decrease in this value is going to cause an increase in the value of the target variable. Okay. Now, so now here you can see that our mutual information plot has run, and you can see that these are the different values of the importance. Now you can see that none of them are very, none of them are very correlated, right? So none of them are highly correlated, but there are still some predictability power of 1%, 2% in these values, right? So now let's move on to the binary variable inspection. Now what I want to do is I want to see that how the binary variables are behaving. Now, one of the biggest checks that you can do is see how is the 0 and 1 distributed, right? So if I look at my particular plot, I can see from this plot that at least for bin PS 13, 12, 11, and 10, there is only 2 counts where the value is 1, 1000 counts where the value is 1, and 5618 where the value is 1. So the frequency of 0 to 1 is well into the 99.9%. Now, generally in this case, these four variables clearly are not predictive in nature because they do not have a lot of zeros and ones. So putting these four variables into your production model or into your algorithm might cause you to overfit. So in this way, you can clearly see that which data do you want to keep or do you not want to keep. A general rule of thumb that I use is that the percentage of distribution between the target 0, 1 should be reflected in these binary variables as well. If it is less than that, you can remove that column directly from your analysis. Okay, so here we saw that the distribution was 57300,000, that is 600,000 to 25,000. So you can think of keeping all of these variables which are above 25,000, and you can drop these four variables off the bat, because even if they will be important, what will happen is that they will cause something which is very dire in machine learning, which is known as overfitting. So these four variables may be prone to overfitting. So it is beneficial for you to sort of remove them from your analysis from the spot on, right? Now there's a feature of categorical and ordinal inspection. Similarly, you can do this sort of analysis for the categorical and ordinal features as well, and come up with analysis and then start removing different data points, right? But another quick and easy or dirty solution in data science that you have, I mean, at least especially in machine learning or Kaggle competitions, is to use feature importance as a way to directly understand which of the variables are actually clear, right? So one thing that you can do is just simply put a baseline random forest model and plot the feature importance. And by plotting the feature importance, you will get to know what are the variables that are better for your algorithm, and using those variables you can try to create new features or algorithmic features. I will cover algorithmic features in some time, but for now just focus on getting the feature importance. So because we are using sklearn library, and sklearn library is a little slow in calculating the models, that is why the model might take a lot of time to based on your machine specification. And also note that this is a hidden data set, so it might actually be a little bit time taking. I'm running it on a MacBook Pro 16 GB, so it's still taking time. But anyways, yeah, it's done training. And I'll also cover some of the newer algorithms which you can use, which not only take less time, but can also help you perform more better iterations in a similar manner. So from this, what I could clearly see is table in your data set, followed by PS indicator 5, PS indicator bin 7, and PS region 03, and similarly. So you can clearly see that you have some variables which have some predictive power, but most of them, as we had already foreseen, do not have a lot of impact, because you can see that their importance is well into the third decimal place. Some of them do have still good importance. This is 3%, this is 5%, this is again 3%, but a lot of these variables are well into the third decimal place, so do not give you a lot of boost, right? If you want to do a bar plot similarly in a descending order fashion, you can clearly see that these are the top 10 variables that you can use. And again, you can clearly see that the visualization quality that I have in Plotly is much superior. You can actually download it as a PSD, you can zoom in specific aspects, you can zoom out, you can auto scale, you can reset, you can compare, you can highlight certain fields. So when you are trying to do a proposal, just one second. Yeah, when you're trying to do a proposal or you're trying to showcase it to a client, I would highly suggest using the Plotly graph frame, right? I think you have a question just saying, could you please explain why the categorical variables with higher value of 1 would overfit? Okay, I think I need to make myself a little more clear on the above point. So let me elaborate it a little more. So over here, you can clearly see that your zero count is much, much more than the one count, right? So what will happen is, let's say by chance, for these 222 values, there were occurrences when the claim happened. Your data set is of 5 lakh records and only 222 records are ones. And from these 222 records, say you got 100 positive claims. So the algorithm would treat this as a very important variable. But in fact, if you look at it, this variable is not that important because the occurrence is only 222 records out of 6 lakh records. So if you look at the occurrence, it is less than 99.99%. So your model might be learning noise. So that is why if you include these 4 features, again, there are chances that your model might overfit. And that is the reason that you would try to avoid adding these variables. You would want to add only those columns where the ratio of 0 and 1s is at least 5% to 95%. Right? So moving on, we got the feature importance plot over here, and similarly we got the bar plot importance here. We could also do another thing is simply put a simple decision tree to visualize how our rules are being made, right? So let's just do that and try to visualize a simple tree. Again, we see the same statistics that were being reflected in random forest pop out, that at the top you have PS car 13, which is being used to split the data. Then you have PS indicator 17, then indicator 5, 4, and then that's about it. So you can clearly see that these 4 variables are the variables in which you should target and try to manipulate, because these are the most important variables that are coming out in your different classifiers, right? Similarly, if you do the same exercise with a GBM and try to see the results, let's see if GBM throws a different result, or results in a different light. Guys, this is going to take a little bit more time because of the high data set, but trust me, do not worry. It will come out. For your practice, when you go back and you want to redo this particular competition, what I would suggest would be, if you are constrained by your specification of laptop or RAM, either move to the cloud. GCP gives you $300 fee worth of credit, so you could instantiate a server and run this over there on a 32 or 16 GB RAM data. Or you could sort of take a subset of this data and run this exercise on just that subset of data. If you used a randomized subset and only retrieve 100,000 records, it should still give you the same outputs. So you could do that as well, right? So let's just give it a couple of seconds for it to run. Yeah. Now what I see is that my random forest and my gradient boosted trees, both of them are sort of showing me the same landscape as before. If I look at both of these graphs, again, it is sort of indicating the same features coming out ahead, although over here we have, some more features more prominent, but all those features which were important in random forest and decision tree have also come out to be important over here as well. So this shows that there is some uniformity in the data, that is, all of our 3 algorithms are sort of giving weightages to the same sort of categories. So that means that the data set is following a particular trend or pattern, right? So this is known as a very cursory or very low level EDA. Obviously, once you are given a lot of more time to sort of go through the data, one suggestion would be to do individual plots of each category and see how the target variable is varying between each category, and try to see if you can create other features as well or not from it. I'm going to cover the I'm going to talk about 10-15 minutes in the feature relation part as well. But before that, I want to show you another Jupyter notebook that was created, and I want to run you through that as well. So now what happens is, a lot of people ask me, and this is a very genuine question, is how do you decide whether you should focus on a low level algorithms such as linear regression, logistic regression, decision tree, or a high level algorithm such as GBM or random forest or deep learning, for that matter, for the deep learning enthusiasts that are there in within the audience, right? So one of the ways in which you can actually get this insight or analysis is to do something which is known as principal component cluster visualization, or TSNE visualization, right? Uh, I am not going to go into the mathematics of principal component. I would trust that you have already gone through that, but I would highly recommend that you guys go through what it means to say that there are two principal components or three principal components in your data set, and then try to visualize those principal components to see whether your data is linear or not, right? So I'm just going to get into a little bit of mathematics, just bear with me. Now your decision tree classifier and your linear regression or logistic regression classifier works when your data set is not that complex. If the complexity in your data set is not at all very complex, you can use linear and logistic regression and get results at par with your high fancy state of the art methods such as random forest and GBM, right? So the question that you now need to answer boils down to, how do you see or how do you visualize whether your data set is complex or not, right? So for this, again, I found a really beautiful notebook that I used to sort of do that deduction. And let me share that. So there is a notebook known as Dimensionality Reduction, where a person has tried to answer this question, that whether your data is complex or not, right? So let's get into that. So one of the methods or one of the techniques that you can use to answer this question, that whether your data is complex or not, is known as principal component analysis. Now, at a very small level, think of it this way: your data is in a n-dimensional space, and you are throwing its projections on a 2D axis. Now, if your data is linearly separable, you will clearly see that that data is properly segregated. But if your data is not very linearly separable or is very complex, you will not be able to see trends or patterns in your data when you project that data in a two-dimensional space, right? So in order to do that, let me run this particular Jupyter notebook and show you the results. So this is loading the data, right? Yeah, give me a couple of seconds, guys. I'm just having a sip of water. So what I do is I run something which is known as principal component analysis on my data set. For now, I think in your courses you might have gone through it, but for now just bear with me and understand that it throws projections into the first and second coordinate system, right? Now, as soon as you do that, what I want to do is I want to draw a plot of this on a graph and see whether my 0 and 1 data is separated or not, or can I see some separation or not. If I can see my ones, or you can see my zeros and ones are properly segregated on this graph, that would mean that my data is not at all complex. So I can use a simple decision tree classifier, or I can use a random forest, or not a random forest, a linear regression or a logistic regression classifier, and get the same accuracy as any of these metrics would have, right? Now let's look at the graph. Now there is a lot of interesting insights in the graph that you can see. One thing you can clearly see is that my data is segregated for sure. So you can clearly see that there is a nice separation between various group of customers. So that means that there are specific distinct customer groups in your data set who are buying your policies. So from a marketing perspective, you can actually use this visualization and show it to your marketing team and say that, hey, you know what? There are these 15 or 20 different clusters that exist within your data. So from a clustering point of view, you can clearly see that there are good clusters present in your data. But when you try to segregate it between 0 and 1, you can clearly see that there is no such segregation. You can clearly see a good mix of blues and reds, right? So from here, you can clearly see that since there is a lot of blues and reds in your database, you can clearly see that that this data is not that linearly separable. This data set is complex. And because of this complexity, you are better off using highly complex models such as GBM and random forest and deep learning for that matter to achieve better accuracy, right? Now, what also you can do is there is another technique known as TSNE, which is a counterpart of PCA. But what it does is it does a similar exercise, but it preserves the orientation of the data. And over here also you can clearly see that you have a lot of clusters in your data, 1, 2, 3, 4, 5, 6. But you can clearly see that it is not able to separate out the white and the blues. The white and the blues are still non-separable, right? So this is the code for TSNE that you can actually use and get this visualization out. But TSNE is an expensive step. It takes a lot of time to run this particular algorithm. So if you are running this, I would suggest that you should have either a good RAM, or you can leave it running overnight on your data set so you are able to get a proper distribution, right? Similarly, you can again run this database by scaling and pre-processing your data, and then again trying to visualize the clusters. So let me just run this visualization and see if we are able to get something out of it or not. Let's give it a couple of minutes to run. Hmm. because this is a big data set. It might take a couple of minutes, so bear with me, please. And if okay, could you explain how? In the meantime, let me field a question. Uh, could you explain how 20 groups could be identified through PCA? So just look at this graph. From this graph, so what I have done is I have projected my data, the complex data, 500 records data, 700, 800 different dimensional data on a 2D plane. And when I print this graph, you can clearly see that there is separation within data, definitely. So for example, this data is close together and this data is not so close together. So from here, you can clearly make out that there is good separation within your data, and there are groups that exist, right? So you can see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and so on, 20, 25 graphs. So let's say if you were doing, let's say if you wanted to do customer analysis, that how many people, what type of people are buying your particular policies, this data would give you some really interesting insights. So that is how you can get to know what sort of graph are there, right? And someone says that, does this mean we can use clustering analysis? Exactly. I do not know how long in the course are you, but one of the ways in which you can specify or see whether your clusters are accurate or not is to use PCA and see whether your clusters have been properly segregated or not. If they do, then this comes out, right? Does not decision tree come under complex algorithm, but also extracts non-linear patterns on the data like? Yes, decision tree is one level non-linear. It is able to capture non-linearity, but only to a certain extent. If you go back to your decision tree class, there is also varying level of non-linearity in your data, right? So linear regression can find out a linear pattern. That is, it can fit a straight line. Decision tree can fit boxes. But let's say your data has a different decision boundary, such as oval, orthogonal, or isotropic. In that case, even your decision trees will not be beneficial. In that case, you might need to resort to random forest or GBM. So definitely, decision tree is non-linear, but at the same time, it is less non-linear as compared to random forest and GBM, right? So now we've run this data, and here you can clearly see that again, patterns are emerging, but there is not a lot of there is not a lot of red or right. But another interesting point that comes out over here is that on the bottom right hand corner and the top left hand corner, we can clearly see a clustering of the reds. So maybe there is some separation in the data, but otherwise you can see that there's uniform sparsity of blues and reds, right? So this is a TSNE plot and it looks like a freaking brain. But from here as well, you can see that clearly there is grouping of data, but there is no clear-cut separation of data, right? So you can go through this Jupyter notebook at leisure. I have uploaded this Jupyter notebook to my GitHub link, and my GitHub link is open source, so you can just clone my GitHub and you can rerun all of this analysis. The only thing that you would need to do is specify or just change the location of the data that you can download from Kaggle, right? So my point is, let us say you are in a business context and you want to justify to a particular department to the reason that why you went for a GBM or you went for a XGBoost model instead of say a decision tree or a cluster. These visualizations will help you a long way in convincing the business that because the inherent data itself is complex, that is why you had to use this approach. You had to use this approach. go and go ahead with a complex model, which is feature engineering. Now, unfortunately, I do not have a particular Jupyter notebook that I had saved to sort of streamline the feature engineering part. But what I would say is you can go through these kernels, which are superb, and they give you a lot of different insights into the feature engineering segment that had to be done in order to solve this particular problem. All right. So with that respect, one of the things, and now I'm going to go in bit of a monologue speech over here, but in that respect, what you can do is from our initial analysis, one second, let me pull up the initial analysis file. Yeah, from our initial analysis, here you could clearly see that we have some variables which are definitely impacting models, even the nonlinear and the complex one, which is PR car 13, PR rec 03, PR indicator 17, and PR indicator 05. So what you could go ahead and do is create a certain set of algorithmic variables. One of those is to simply create cross-sectional feature, that is multiply two different categories and create a new category. Or you could also create squaring of these categories. So for example, PS reg 03 is a continuous variable. So why not also do the log transformation, do a log transformation, do a square root transformation, get the square, cube, the fourth power of this particular variables and try to apply it within a model. Similarly for PS car 13, from what I can see is it is again a continuous variable. So again, you can do all sorts of manipulations and algorithmic variables. One thing you could do is you could get the mean of this particular variable and create a dummy variable which says that whether the value is greater than the mean of this particular variable or not. So you can try all sorts of algorithmic, permutation combinations to understand what are the different features that might be beneficial for this particular data set, right? So when you do that, you will be able to get a lot more algorithms in your data set. So I think I have a couple of questions which I'll again field. You are running PCA on AWS? No, this is as of now my local laptop. If you're running PCA, you can run it on your local laptop, it is fine. But if you want to go to TSNE, which is another form of component analysis, that takes a lot of time and a lot of compute power. So that I would suggest that you go to AWS. Why do you need to transform those variables? Why you said we need to transform those variables? Could you please explain? Yeah, I am not saying you need to transform these variables per se. You can directly use these variables into your data. But maybe the accuracy or the precision of your model increases when you start squaring the data, because then your algorithm is able to discern the positives from the negatives more clearly. So that is the entire concept of feature engineering. You can use the raw or the base features that you have as it is directly into your model. But what may help you as well is to also try different variations of these features by, going for the first cube root, the second cube root, the third cube root, the fourth cube root, square rooting it, taking the log transform, taking the inverse transform, etc. Or what you could do is you could also try binning these particular variables as well. It depends upon the time that you have with you to do the feature engineering bit, as well as the complexity to which you want to go to achieve this methodology. I hope that makes sense and is a lot more clear to people. So let me move on to the next part, which is going to be simply now running an algorithm, right? Now, in order to run an algorithm, what you could probably do would be, there are multiple algorithms that you can use, But the state of the art algorithms that are out there, which every data scientist or Kagler deadly uses, are two. One is XGBoost. I am currently using XGBoost I am not really sure if you do. You can check out XGBoost, and which has lot of I think there's some uh, lag in my internet, so pardon me for that. Right, right. So this is the light GBM implementation. Now here you can see that why people prefer light GBM. A is because it is present in a multiple of languages. If you are using C as your developing style, you can use C, you can use Python, you can use R. And the second is that this has been incorporated by Microsoft. And as you know that Microsoft has a brilliant array of products. I personally recommend using light GBM as the default GBM model. The reason is that A, it is fast because of which I'm going to show you anyways when I run an entire output. B, it has some inherent optimizations which at the algorithm level happen. So I don't know if I should go into this or not, but they have added regularization within GBM so that A, it is less prone to overfitting, and B, it generally helps you achieve higher level of accuracy in your data set, right? So that is the reason that I generally prefer using light GBM. And if even if you have 1 million records, 2 million records, 3 million records, it is able to handle that data set in a quite robust fashion. They don't go into the lot of the mathematics of how they have used to sort of derive this particular data, but on a similar fashion you also have XGBoost, which is again an improvement over the existing sklearn GPM implementation. So this also helps you sort of get a boost out of your model and out of your data set if you are doing any GBM level implementation as well. Uh, Another thing that you can do is here you can see that you can also run it in a distributed environment. If you have a huge data set, you can use it in Kubernetes. I don't know if a lot of you over there have a data engineering domain, but Dockerization and Kubernetes is another thing that is really high in the market. So you can actually run Kubernetes Dockers and do this implementation. So this is more from an implementational point of view. I'm definitely going to touch about the implementational aspects as well, but that's going to happen at a later stage down the line. uh, if you guys have any doubts regarding these two algorithms, let me know as of now. Right. uh, okay. uh, how did you figure out that these are the variables to be transformed? Okay. So that is again goes back to my EDA aspect. Over here, you can clearly see that only those variables which have a high feature importance are the one which I will use for my transformation. Okay. Uh, from this graph, I can clearly see, but if this graph is not clear, you can take this graph as a barometer and then put a cutoff. So let's say I'm going to transform only those variables which have a feature importance of greater than 2%. So you are going to take all of these features up from PSCar03 and you're going to do the transformation on these particular categories. Guys, I hope the audio is uh, clear now. I see a lot of comments saying that the audio was not clear, but I hope now that the audio has become clearer and better. Okay. Another question was, do you have any pointers as to which transformations we should try, or is it random? I would say that it is random to quite a certain extent. What you should do is you should try one set of transformations, run your algorithm, see the validation. If the validation score is improving, that is the transformation you should use. If the validation is not improving, you should sort of skew from that particular transformation. So it's more of a black and white sort of a picture. Just try to use those algorithm, those transformations which are giving you a better uplift, right? You could try to do the transformation of all the algorithm with the same method, but the issue that you'll run into that would be that it will take a lot of time. You have 60 different variables and you have 500,000 records. Let's say if you just square all of these variables, that will give you 56 into 2. That is 120 variables. Go to the cube root, that will give you 180 variables. Go for the log transformation, it will give you 400, 500 variables. Now, mind you that as you keep on increasing the transform variables, your data set will also keep on increasing. And as your data set increases, your algorithms will take more time to do the training. So it's going to be a better trade-off based on A, the time that you have, B, the compute that you have, and based on that, you have to decide on a cutoff on which you want to do those variables, right? Yeah, when you transform the selected variables, you should try all those selected variables. You should focus on transforming all of them because you do not know that which one might respond to which particular transformation, right? Yeah, you're right. We should first square, first of all, etc. What are the two algos you talked about? So yeah, I'll come to that. These are gradient boosted algos. The name of these algos are XGBoost and LightGBM, right? So you can go through the documentation and let me do one thing. Let me add this in the question link so that all of you have the documentation in place. These should be your go-to algorithm as and when you start doing a data science. Yes, when you do apply this transformation, it is your choice. You can keep the untransformed variable as well. See, I am going to go back to a very famous problem, very famous proverb, which might make you laugh. That is, data science is more an art than a science. So there's no right and wrong here. You can do any sorts of permutations only until and unless you are able to get a boost in your accuracy, improve your model, and at the same time, you are able to reduce overfitting. So till the time you are able to do that, this should work. How do you deal with skewness in the data? It is pretty normal. You can again go for transformations. You can do the log, the underroot transformation, which will help you reduce the skewness in your particular data set. So that might also help you reduce your skewness. Give me a second, guys. Let's move on to the Jupyter exercise. So now I'm going to run you through again a notebook which I used and which got me a rank of about 400 out of the 6,000 participants in the competition. And this essentially only used the XGB classifier, which is essentially the XGBoost documentation that I just showed you. But the beauty of using XGBoost is that it also gives you implementation of data engineering. So this will also help you get uh, your data production ready if you use XGBoost trees as well. Okay. So starting with that, guys, so now I'll field more questions in about 10 minutes time. So now I want to run you through end to end the code that I used to get a submission in Porter Seguro competition. And this submission helped me get, I think, a rank of about 300 or 400, which is when we were at the competition stage. And eventually, using this and an ensemble of multiple models, I was able to get a score of 250 folds. So, okay, starting off, what I did was, again, I ingested the train and test data, dropped the ID variable, and then what I started to do was I dropped the calculation features. The reason I dropped the calculation features was that if you go and look at the EDA part, you'll see that the calculation features are at the very end. They do not really come into and some construction of the PS regression. So here you can see that I try to square the PS regression 03 variable, the PS car 04 variable, right? And based on that, I was able to create a reconstruction. After that, I did some transformations of creating the median and the median. After that, I did some transformations of creating the median and the range variable.
Sorry, Puneet, your voice is breaking.
Base level initialization I did. At that point of time, I added a column where I got the skewness, the
Puneet,
mean,
can you hear me?
and the PD of the variable as well, and then I did the coding. So you can my algorithms. They use the multi. Sorry.
Yeah, Puneet,
Yeah, I can hear
actually,
you.
your voice is not coming through.
Can you hear me?
Slightly better, but it was breaking for the last minute or so.
Okay. Guys, give me 1 second. Let me just. Okay. Give me a second. Let me just see if I. Let me just switch to my Wi-Fi again. Let me turn off my Wi-Fi to get a better connection. Yeah, just give me guys 1 second. Yeah. Guys, is my audio quality better? Hello.
Seems better, Puneet.
Okay. Does it seem better now?
Yes, it does seem better.
Okay. Yeah. So, Atash, please feel free to like sort of interrupt me in my flow because sometimes I
Sure,
don't
sure.
realize my voice is breaking.
Sure,
Yeah.
sure. Will do.
Sorry about that, guys. So what I'll do is I will go back the next. I'll sort of repeat the last 2 to 3 minutes of the notebook that I was trying to explain. So, anyways, so starting off, this was very simple. Just ingesting all of the data that we had uh, present in the model. Then, just getting the data set in and doing just the cursory things, storing the target as a Y variable, dropping the test ID because the test ID was just essentially uh, the customer ID and it was not giving any sort of uplift and it wasn't there wasn't any leak in it, right? After that, what we did was, as I mentioned, I tried to do a lot of combinations of squaring and cubing to try to see if whether it sort of gives an uplift to the model. Then I also tried to do the median, mean, skew, and then add it as extra features in the column. Also, I created a median range and a mean range column wherein if the value was greater than the median or the mean, I created a new binary variable from it, right? Again, you can clearly see I also created an interaction variable with the top two variables, which was ps car 13 cos ps reg 03. So I tried a host of things, and finally, if the data was between 0 to 7 categories, I one hot encoded those particular columns. Now there were categories which had a lot of variables. I did not one hot encode those because that would blow up my feature space and cause my training time to increase a lot. So that is why I only used those particular categorical variables which had value between 0 to 7, and I one hot encoded them as well. Now, you could argue you could treat them as categorical variables, you could classify them as label encoders. See, at the end of the day, this is a Kaggle competition, and in real life as well, people do not care how you came up to a particular solution till the time that your solution is robust, free from biases, and is productionable. All right. So that is the reason that I chose to go with this particular transformation methodology. And if I show you my document page, you will see that I have a host of different scripts, and all of them have different features or different variables that I use to sort of get a lift, right? So after doing this, what we had, and that is another reason why I used XGBoost and GBM, is you can actually specify your own custom loss functions in these particular algorithms. And if you look at a problem statement, I had clearly called out that we cannot use accuracy or precision or recall to sort of get the optimum results that we want. We needed to have our own algorithm. So they have, fortunately, you can over here see that they had given the entire calculation of how to create that particular algorithm or how to create that particular value. And just using this, we were able to create the same evaluation metric in Python. And I've also added exactly from where you can get the fast computation, and the algorithm was going to optimize on this particular loss function instead of, say, your accuracy or your log loss function. So this is another boost that you can use to sort of optimize your model. Next, I had used the same parameters that I had for, I was going to optimize my XGBoost parameters. Now, there are a couple of ways you could do this. I had already run the grid search. So there are a couple of ways you can approach of how to you can hypertune. One is to do normal grid search where you specify a matrix of all the possible parameters you want to iterate over. But you can also use something which is used known as Bayesian optimization. Uh, okay, sorry, I think my screen is not refreshing. Let me share it again and stop and share it again. Guys, can you see my screen now? Just let me know if you can still see my screen and you can see it moving. Give me a second then. Sorry about that. I think my screen is not refreshing. Just give me a second. Is it now refreshing, guys?
It's stuck, Puneet. So let me do one thing. Let me just stop. you from being a presenter and give you back that access again.
Yeah, perfect. Thank you.
Yeah, you can try now.
Okay, thank you. Now is it visible?
I don't think it's shared yet. No, it's not been shared yet.
Okay, I from my end I am stop showing screen, show screen. Now is it being shown?
No, it's actually not.
One second. Uh, should I just log in and log out and log in once again, just
Yeah,
quickly?
I think that could work.
Yeah. Sorry about that. Guys. Just logging back in 1 second.
Sure.
Hi guys.
Yeah, try sharing your screen.
And now is it sharing?
Yeah, it is.
Okay. Thank you for that, Atash. Sorry guys for the delay. Uh, Apologies. Okay, perfect. Yeah. So going back to my code, guys, I am assuming that you guys were able to understand, hear me clearly. So I'll just again go back to the code that I was showing. So this is essentially the Gini calculation. They have already given the Gini calculation, but if you did not want to use a Gini calculation, you could have just gone for an EUC score as well. Uh, Both of them work in a very similar fashion, so using one over the other is not going to change your statistics by a lot. So I would highly recommend that as starting out in this competition, first of all go for AUC. Always start slow and then add on complexity. First of all, do the things that you do know. Go build a baseline model. Do not do any fancy things from the start. Build a baseline model, use the same metrics. After you build the baseline model, then think about what you want to improve and how you want to improve about it, right? So one of the ways I could improve about it was swap out the AUC score for the one that they're actually looking at and try to optimize on that. And that is what I did over here. Second would be that if I'm using random forest, GBM, or decision tree, I have a lot of hyper tuning parameters that I can leverage. So I start off by not doing any sort of hyperparameter tuning, and then slowly thinking about how I can build out and do a hyperparameter tuning. So I'm not going to go into the detail because I'm pretty sure you guys will be aware that it's just a grid search where you sort of search all the combinations. The only thing I would say would be that as a data scientist, as well as a professional data scientist, as well as a Kagler, I would say that when you're dealing with large data sets, running those permutation can take 2 to 3 days. So what is beneficial is that when you are doing those permutations, it is always good that after every step, you write out the permutation that you did and the cross validation you got in either a log file or to another system. The reason is that sometimes, for whatever reason, your Jupyter notebook stops working, your server crashes, your laptop crashes, and if you do not have a logging mechanism of how many iterations have you completed, you'll have to start all over again, and you might end up spending 1 or 2 days of additional effort. So one of the tips that I can share with you is always try to create a log file or a simple CSV file which has the record of all the iterations that you have built out. I have already made a code for the logging mechanism, and I will run it through when I'm doing productionizing the code with you. Once I go through this particular piece of code, I will jump on and then I will explain you how you can productionize your code, create a log file so that you have a record of all of these things that keep on happening with you. So that even if your data is lost, up till the point that your algorithm was running, you have a record of all the data sets. So you can start from there. For people who know a little bit of deep learning, this is also something which is known as callback. So that even if you stop your training at a particular point, you can just pick up from where you left off. All right. So over here, you can clearly see that I am using something which is known as XGBoost, and I'm pretty sure I think half of you would be aware of what exactly XGBoost is. But anyways, getting into the meat of things, what I do is I specify these hyperparameters which I got after hyper tuning this particular algorithm, which is XGBoost. Now I am going to, now there are two ways you could have approached this problem. The first way you could have approached this problem was to either create a train test split and from your training set also create an additional set which is known as the validation set. So optimize your data point on the validation set and then test on the test set, and based on that get your final prediction. However, in practice, what people have seen is that that is not one of the best methods that you can, you should do your optimization with. You should use another algorithm which is known as k-folds cross validation. What k-fold cross validation does is that instead of you doing a classical train and test split, you divide your data into different folds, and in each run you leave out one fold, use the rest of the data and do your prediction on that fold, so that in each run you are fitting a data, you are fitting a model for each number of fold that you have in that round. So for one set of combinations you are actually fitting the number of models that is equal to the number of splits. So in my case, for this particular combination, I will be fitting 5 models, and of those 5 models, I will be taking their average. And that will tell me what is my average Gini, so that it will help me iron out all of my variation. So in Kaggle, what you'll see is people go for ensembling, people go for a lot of complex algorithms, which causes their single model accuracy to go up very fast. But once they do cross validation, they see their cross validation score crash because they have essentially overfitted the data. And you should not overfit your data. What you should do is you should always use a cross validation strategy and only go for that score when your average score for that round has increased or your average metrics have increased for that particular score, right? For people who are not aware about what exactly cross validation is, I would highly suggest that you go and read about what cross validation is and use it as a de facto strategy for all of your productionizing as well, not even productionizing, even your normal data science work, right? So over here you can see what I do is I create fold and fold number. I use the k-fold, and k-fold is a metric that you get in the sklearn library. It automatically creates folds for you, and you can specify the split. You can specify whether you want to shuffle your data. So what this does is this automatically shuffles your data based on the number of splits that you specify, and this will remain the space. This will remain the same as long as you use the same random state. Okay. Based on this, what I do is I use what is known as out of fold validation. So what happens is that when you are training, you have four. So let's say if you have 5 folds, 4 folds will be used for making the model. 1 fold will be used for predicting, and that is what is known as out of fold validation. I hope that is clear to everyone. So here you can see that iterate for fold underscore, and fold underscore is nothing but your folds, right? So fold underscore, what I do is I fit my light GBM or XG, whichever model you want to fit, your XGBoost model or light GBM model. Over here, I have fitted a light GBM model that I'm going to fit. And another thing I do is something which is known as stratified sampling. And what I do is, because you saw from my interactive graph that the number of zeros and ones was highly skewed, that is, I was getting only 3% ones. Whenever I was going to fit a model over there, I artificially increased my number of ones. So that is known as stratified upliftment. This was helping me get additional boost in my model, because the thing that happens is, because there is a lot of zeros and only few ones, your model is not able to pick up those values where your model predicts one. Because it is getting so many zero predictions, it fails to realize when there is a one prediction. So over here you can see that I am artificially increasing the value of the ones. And after that, after artificially increasing my value of ones, then I am fitting my model. But I'm only doing this for my those folds where I am going to make the model, not on the fold that I am going to predict, because then that would bias your results. So based on that, what am I doing is I am storing all of these values. So if you do that, I'm sorry, I have to rerun this again. And I'm using something which is known as early stopping. Early stopping is again another mechanism in which you do not let it run for all the number of the trees, but you stop it at that point or juncture where your number of trees give you the maximum output, right? So let's just wait for this particular algorithm to finish running, and then I will explain what is out of fold prediction and what are the different prediction values in all of the inherent folds. Now, because now you can see is that this is still training much faster than the training that was happening with the normal sklearn algorithm. So my suggestion to you would be try to use these next generation algorithms such as XGBoost and Light GBM. The reason that I say this is because these are not only faster, but it will help you get more iterations than the one that you are seeing right now, right? So till the time this runs, let me field some questions. Is cross-validation recommended to use on a large data set? Will it degrade the execution performance? At the end of the day, yes, it will cause your training time to go up. But at the same time, cross validation is definitely recommended because the algorithms that we are using, XGBoost, LightGBM, or for that matter, even the fact if you use deep learning or all of those other algorithms, it will take, they are very heavily prone to overfitting. So using cross validation and using a large number of k-fold will at least guarantee that even though you're not achieving a very high accuracy, you are still achieving a model which is not overfitting. And trust me, as a Kagler, I have seen that people during the training time, without taking any regard for accuracy, for overfitting into account, were actually fourth or fifth in the cable competition, till the time there was only the public leaderboard. But as soon as the private leaderboard came into picture, they went back as high as 7 or 800 steps or 7 or 800 ranks. I've seen that happen a lot of time. So I would say that even at the cost of less number of iterations being permutated, I would suggest go with the cross validation strategy first rather than a simple train test split. Yes, it will take a lot of execution time to run right on large data set, definitely. That is why I would recommend using LightGBM or XGBoost sort of algorithms, because they are able to do even large scale calculations at a faster pace. So here you can see that fold one, my best score was 0.27069 Gini. This is on the validation set. Uh, on the fold 2, it is 0.262. And similarly, I'll keep on running this for 3, 4 folds. Okay, so over here you can see that if increase is true, what I'm doing is I'm simply just doubling all those records. I'm just doubling all of those records which have ones. That is all I'm doing, and this is the code which does it. Okay. Is stratified uplift better than smooth or other upsampling techniques? I would not say that it is better than smooth or other sampling techniques. It was just easier to implement in this case. So I went with stratified upsampling. I did try smooth. I did not get a lot of uplift with smooth, to be honest. And that is the reason that I went with stratified upsampling. Okay, this is slightly off topic, but I can come back to this later. Someone just asked me to recommend some resources on to learn data science. I would just say start Kaggling, that would be better. Yes, so someone is asking, so are these exact duplicates? Yes, these are exact duplicates. I just wanted my model to know that there are a lot more ones than zeros. Because at the end of the day, if my algorithm is not able to predict ones, and if it is only able to predict zeros, so in this case, even if we just created a very dummy model which made everything zero, think about it, even in those cases, my accuracy is still 97. But that is not the reason I'm trying to build this model. The reason I'm trying to build this model is so that I can accurately predict what is the percentage, or which is the target group which is able to actually claim better. Right? Great. So I think those were all the questions so far, but I'll keep on taking questions as and when they arise. So thank you for that. So over here you can see we have done three. So I can see that my Gini, if I look at fold one Gini, it was 0.270692. For second, it was 262,078. For three, it was 2609. So my Gini is constantly behaving between 0.26 and 0.28, right? And it is still going. As I said that, so that is the reason that, it takes a lot of time for you to sort of run these algorithms. So you need to be careful of your time as well. So I'll just read this run, and in the meantime, if anyone has any other questions, please feel to write it on the board. Yeah, so I think the fourth fold, so you can see that the fourth fold give you the highest accuracy of 0.281. So you can say that your Gini is ranging between 0.260 to 2.281, and that is the entire lifeline. In real life, is XGBoost really used? Yes. If you would have asked me this question 4 months, 4 years ago, I would have said no. But I myself have put into production a couple of algorithms which use light GBM and XGBoost. And as of now, for tabular data, for example, these data sets, XGBoost is still the state of the art model that is being used. I would not say XGBoost, I would say GBM in general. There are a lot of variations of XGBoost. You have XGBoost in the big data development. You have light GBM. You also have CAD boost. So yes, GBM paradigm is still being used, but at the same time, a lot of variations have gone into place. So you need to decide which variation do you want to use. I have read that it is mostly used, is mostly a Kaggle only algorithm. I would have said that to be the case 3 to 4 years ago, but nowadays I have actually seen a lot of people put GBM algorithms into production as well. I use light GBM. Someone has asked me which GBM you use in deployment. I have used generally light GBM because for my use cases, for the couple of use cases I have tried, it has always been able to outperform the traditional XGBoost, and it is quicker to train, and it also supports GPU optimization, so it'll also help you boost your training time. So I have generally used light GBM in production. Could we understand what kind of variables have non-linear relationships so that we could transform those directly? This is a very good question, and sadly, there's no clear-cut answer to this. But I will say that there are ways in which you can get to know non-linear variables. I would suggest you to read upon something which is known as partial dependency plots. Go ahead and read those out. Those will help you get a lot more clarity on how to attempt these particular problems. For a large data set, I would say it depends upon the size of the data. Anything less than 100,000 records, I would suggest go with a 10K fold size. But in our case, as you saw, we have 500,000 records. I am comfortable using a 5K fold. 5K fold would also be not that bad, and it would still give me robust results. Okay, could you please explain folds? Again, for folds, I would say I don't think right now would be the forum in which I can actually go into detail. But what I can tell you is that you can go back and research about what is the concept of cross validation, understand what is that concept, and then come back to me. Or I'll give you my email, we can reach out and we can have a chat, etc. But essentially it is the object of cross validation. So let's say you have 100 records. You divide your 100 records into number of folds. Let's say we take fold as 5. So what happens is you have divided your entire data set into 10 into 5 folds of 10 record each, 20 sorry 5 folds of 20 records each, because 5 into 20 is 100. Now what you do is you take the first 4 folds, that is 80 records, create a model, and then validate that model on the last fold which you left out. Now you create again a model on the first 3 folds and the last fold, and you validate it on the second last fold that you left out. Again, you create a model on the first 2 and the last 2 folds and validate on the third last fold. And similarly, you keep on doing this. Now what will happen is you have created 5 different algorithms, and you have 5 different validation results. You take the average of those results, and that average will reflect the true Gini that your data set has. In this way, you have also used the test set that you would normally leave out as a training set. So theoretically, you are getting more data, so you are more accurate in terms of your estimation. how do you estimate how many times your minority has to be duplicated? I just use a rule of thumb that the percentage of minority should be equal to or greater than 5%. So if it is equal to 5%, so that is why I just doubled it, because it was 3.5%. So then it becomes 7%. So that is why I just doubled it. Ideally, the algorithms that we are using are robust to such an extent that they are able to understand if the imbalance is 20 is to 1. Anything less than 20 is to 1, they tend to sort of fade out. But 20 is to 1 is something that they can handle, right? How is the missing value being treated in this particular algorithm? If you go at the back end, the missing values are essentially there is something which is known as surrogate rules in LightGBM. So XGBoost and LightGBM, both these algorithms automatically themselves handle missing values. So you can just check the documentation to understand how it handles missing values. All right. So from here you can see that all the 5 folds have completed, and the full out of fold score is 0.026958. Right. And then you can download this validation score, and then you can then predict on the test set and then put this test set in to the Kaggle kernel, and you can get the prediction. So this is typically how you would attempt a light GBM slash a data science problem in Kaggle. Right, guys? So if you look at my repository, I have a lot of stratified samples. So you can see I have up samples, I have done cat boost, I have done XGBoost, I have done XGBoost BFIR. There are a lot of things that you can try, you can apply. Uh, Typically in Kaggle, what really gets you the best is ensembling multiple learners together. So what I did was I took the output of Light GBM, I took the output of XGBoost, I took the output of CAS Boost, I weighted average all of these three predictions, and then I submitted my final prediction. And that was also able to give me a really good boost on my accuracy. So you could try those samples as well, right? Mixing and matching different iterations, different algorithms. This goes back to the power of ensembling. If any of your models or your algorithms are decorrelated with one another, the addition, sorry, the ensemble of this will definitely outperform each individual ensemble. So that has been proven to work every time and around, and that is essentially how you can win Kaggle competitions primarily, right? Great. So now I think I will leave it to you guys to sort of go and see all of my Kaggle scripts that I had used. You can, one way what you can do is, for people who are very new to GitHub is, there is this option known as fork. What you can do is you can fork my repository. So what it will do is it will create an exact replica of my repository in your repository, and you can then build on top of my repository, add more kernels, use more algorithms, also try to see if you can, in as someone was mentioning, use smooth, use different transformation functions. There is still a host of variety of things that you can use, and I have a lot of stuff as well. I have a lot of other competitions that I attempted as well, so you can also get a rip the codes from there and then start building your own codes from there on as well. All right. So now again I would like to draw another distinction over here. Although in Kaggle we use ensembling as the bread and butter. Yeah, for the last 10 minutes, definitely I can go through all the projects that I have done. I have my codes embedded in those. I can also tell you what are some of the commercial projects that I have done. Someone has asked me that for the last 10 minutes, can you tell us about how you started with all the projects you did? So definitely I can tell you all of that in the last 10 minutes. So bear with me. So as I was saying, in a Kaggle competition, what happens is that you want to just increase accuracy. So let me just this now I'm going to show you the dark side of Kaggle. So let me go to the leadership board, right? This is my Kaggle homepage. So you can see, like, let us, the top guy had 0.296 and I had a score of 0.2902. So mine and the topper's difference was on the third decimal level. And if you go from here, if you go right down from 45th rank to my rank, it was actually in the fourth decimal space, right? So in practicality, for a business, this difference in the third or fourth decimal space did not make a lot of issue. All right, they do not have that big an impact. I'll be very honest with you guys. What really makes an impact is the first and second level. If you are able to boost your model by 2 to 3%, that will definitely help the business. But going till the fourth decimal level space will not help the business. And this is where ensemble comes in. So to answer your question, in production, I have generally always used only a single model. I have rarely gone on to use an ensemble model because ensemble models tend to heavily overfit after a certain point of time. So my suggestion to all you novice skigglers or data scientists out there is try to improve the single model as much as you can and then go for ensemble. Ensemble is generally a technique that is used in Kaggle competitions to increase the capacity, but in normal algorithms, generally I would not prefer to use ensembles. I hope that that is clear on that particular aspect, right? Next goes productionization. Now I'm going to, I think we have around 50 minutes with us left to cover. So I'm going to cover the productionization aspect with you guys. For now, I'll just take a 2-minute break to just grab some more water. I'm getting a little thirsty. So just give me 2 seconds and then we can go ahead and we can talk about how do you productionize an ML code. I'll take 20 minutes for this and then we'll move on to how do you deploy it into production. What are the various ways in which you can deploy it? Then I'll show you snippets of AWS where you can actually go and write production level codes, or you can actually productionize codes directly. For this, I will recommend that all of you who are learning data science also get comfortable with the concept of APIs, that is application packaging interfaces, programming interface. So I'll just reconvene in 2 seconds, 2 minutes. Okay, guys, I'm back. Sorry for the disruption. Great. So now let me go back to productionizing the data. Now, over here is something that people who are familiar with Java or familiar with, you know, other C, C++ languages would be familiar is when we're trying to productionize a code, we generally think in terms of classes or we don't think in terms of modelization. Now, why that is beneficial is because if in future someone wants to make any addition or many subtractions to that code, they can do so without disrupting the entire flow. All right. Now, let me give you an example of, let's say this. This was a particular Jupyter notebook that we just ran and we saw how it worked end to end, right? Let's say after 1 year, you saw that your model was not performing accurately or a new algorithm has come in, right? And that algorithm is essentially, let's say, deep learning, right? So you want to swap out your deep learning, your light GBM algorithm with a deep learning algorithm, right? Now, what will happen is you'll have to do a lot of manual changes up and down, and then you'll have to test it accordingly, and then you will have to see whether it is working correctly or not, right? Now, what happens is in this case, there is always going to be a risk that you do some changes which have unintended consequences, or you do some changes which are properly not reflected. So you need a better way of categorizing your code. So in productionization, there are two school of thoughts that you can follow. I sort of tread the line of both. One is modularization. That is, in your code, there should not be any sequential data. Everything should either be created as a function, or either everything should be created as a class. All right. So both of the school of the, I'm not going to get into the debate of which school of thought is correct and which school of thought is not correct, because both of them have their positives, both of them have their negatives. But what I would recommend would be that if you guys have a good Python, if you have a good coding experience, going towards the going towards the path of creating classes is a better approach. But if you are just starting out, then modularizing or creating functions out of everything would be a better approach. Once you are more comfortable with modularization, then you can go ahead and think about classes. But classes is not a necessary tool that you need to understand to modularize your code. You can just do with simply creating functions. Okay, so let me give you a brief of how I sort of modelize this code, right? So over here, what you have in modelization, what you do is you have a main.ipynb function which runs all of your code. And if you look at it, what happens is my function is just these many lines. These are the lines that I run to get my function, and all the other parameters are either classes or are modularized functions. Now what this gives me the ability to do is, in future, if I want to do any changes or modifications, I don't have to change the entire code. I only have to change that particular function, right? So let me give you an example. If you look at my code, what I have done is I have created a logging system wherein I create a log file which stores all the details of that iteration run. I then also have a load data. I have a function which helps me load the data. So you can see that I've created this function which actually helps me load the data. Now let's say in future this data did not come in a CSV format, it came in an SFTP format, or it came in whatever format, right? So what I would need to do is nothing. I would just need to swap out this load function for the new function. So that is why modularization is much more beneficial than your other algorithms or your other paradigms, right? So how you go about modularization is just think of all the codes that you can break down into small silos, right? So let's take in a typical data science pipeline, what are the broad modules that you have? You have, first of all, you have data ingestion, right? So that is why if you look at my code over here, it is written load data, right? Then comes the data preparation part. So over here you do the data preparation part. So in this it will be all of your feature engineering, data transformation, data resizing, factoring, scaling. And over here you can see I have created a lot of different parameters. Do I want to one hot encode them? Do I want to target encode them? Do I want to reconfigure the region variables? Do I want to remove the calculated fields? So this way what you can do is, even in future, let's say you were doing this exercise again and you had some different transformation, what you would do in this particular case would be you would just simply swap out this train test prep data for your new function, right? So this will help you a long way in, keeping your code clean. And what this will help you do is, let's say this was my first Kaggle competition. As soon as now I move on to the next Kaggle competition, I will be able to leverage most of these codes, right? So now, for example, I told you, right, that we had created a custom function, Genie function. How I am calling that function, I'll show you. I have a folder known as utils, and over here I've created a folder known as custom logs function, right? So let's say tomorrow I am doing another Kaggle competition, and what happens is that they have a new function on which we have to optimize our entire project. So me, instead of writing huge bunch of code, I just need to add that function here and then simply call it in the parameters, and automatically my new algorithm will automatically take the new custom loss function, right? Similarly, as I said, I have also created a folder for different machine learning models. So I have, as of now, light GBM model. What happens is that if in future what I do is, in ensemble, k-fold ensemble, right now I have specified the classifier LGB, but in future if I want to integrate XGBoost, I will simply create a folder here and then run the XGBoost command. So what it will do is, my code is neater, cleaner, and in future if I leave the organization, or if say someone else wants to pick up my particular project, they can do so in a quicker fashion. So that is the entire concept of productionizing the code. It should A, have good readability, B, should be modularized, 3, that any other person joining your organization should be able to quickly leverage the code and start building on top of it. And fourth, which is very important, is known as code reproducibility. By code reproducibility, what I mean is that if I wanted to say start a fraud detection project, I should be able to leverage 50% of this code, and I should only do 20 or 30% more coding to make my current code compatible with a new code. All right. So this is what is known as productionization. Let me run this for you. Again, this is load data. These are all the loading functions. And as I said, it is always good for you to create a log file so that in the event that my system crashes, or say if you are, see, at the end of the day, you could clearly call out that I did not run one code. I ran hundreds of different codes, right? So it is important for me to document all the codes that I ran, right? So for each run, if I create a new file, what it will do is it will store all the details that I used to create that particular run and store it in a separate log, so that in future when I want to recreate, let's say for example I ran 100 simulations and I was constantly tweaking these parameters, and one of them gave you a good score, but you don't know which one gave you a good score. If you keep on creating different log files for all the scores, It will help you create a track of which particular algorithm was giving me which score with which feature engineering in place, right? So for now, let this run, and I'll show you the log file. Yes, now it has stopped running. So now what I do is I have these logs folder where you can see this first log has come up, and over here you can see I have started storing all the variables. It is storing my fold level detail. It is storing all the variable importance that I have, and it is also telling me what I wrote out to the what was my output, right? So now I can go one step further. I can also start storing all the other things as well. I can store all the parameter specifications, parameter configurations. So if I want to recreate that model, I have everything, and I can simply do that. So now what I do is I simply write this as log v2, and I change my parameters, right? So for now, if I have early stopping around 20, I make this 125, and then I let it again run. Yeah, so guys, I think the second iteration is still running. So let's just see that. Yeah, I think it has run. So now you can clearly see that I have got the log of the second result as well, right? So you can clearly see I have fold 1, fold 2, I have best of both scroll iterations. So this is again a good practice that you should do, that when even if you're using cross validation, or even if you're using k folds, or you're using uh, I would say grid search or optimization search, try to put logs or a CSV file so that it is handy, and you can then recall that where your log was stored at what particular point of time. All right. So I think this was all in terms of productionization. If you guys have any question on productionization, please feel free to write it in the questions, and I'll answer that for you. Otherwise, we'll move on to the next part, which is how do I give the outputs of this production? So let's say you've productionized your code is productionized. Now, how do you put it into deployment? That is one of the biggest, I would say, concerns right now people have. It's okay if you spend 6 months productionizing your code and getting it out of the pipeline, but after that the business wants quick results. In order to achieve quick results, business wants you to give back, or to put this into production in a very fast pace. You cannot hand it over to an IT guy and say that hey, he's going to integrate it in 6 months, because that means that you're losing business sense, right? In terms of deployment, there are two particular ways in which you can deploy a particular code. All right. Namely, one of them is known as batch deployment, and the other is known as real-time deployment. Okay. In batch deployment, what happens is that let's take, for example, let's take this particular question, right? This is a classic case of real-time deployment, because what will happen is you might have a website, you might have a call center, or you might have a third-party agent who people go to buy their insurance. They will feed in all of their details, as we could see all of the data fields, for example, the name, the age, the location, what is the model type, what is the car type, what is the premium, and based on that they will get one price. So as soon as a person enters all of these different variables, you should give out a prediction telling what is the probability that he's going to claim next year, which is going to be fed into the pricing engine, and then a real-time price is going to be generated. So this is a clear-cut case of real-time prediction, right? But let us take another use case, for example, fraud detection, right? Let's say you are an insurance handler. Let's take an insurance example again. Let's say that you have built a fraud detection system wherein as soon as the claim comes in, you can trigger the investigation agency whether this particular claim is fraudulent or not. In this case, you do not need a real-time fraudulent checker system. Because the claims typically take a month to process, what you could do is let the claims come in for a week. On a Saturday, run your algorithm on all of the claims that have come in for that particular week, and then send out the 200 or 300 most fraudulent claims that you think are fraudulent to your claims handling department, flagging that these particular claims are suspect. So in this case, you do not need a real-time algorithm. What you actually need is a batch algorithm which runs your predictions on a bulk data set and then shares those predictions, right? Now, these are the two typical production systems that you have in place that you want to get the predictions out of. Okay. Now, for the batch predictions, it is pretty easy. You could schedule your script to ingest a data, run a Python script, and then that Python script would run on that scheduled time, create a CSV file, and then that CSV file will be shared with the relevant stakeholders, right? That can be easily done. But what about the real-time integration? And let's say, how can you make this particular entire algorithm so robust that you have written your entire data science program in Python or R or C++. Your IT team is using .NET, Java, C++, C# to write their code and to integrate your software with theirs, right? So let's say you created one particular script. They have to recreate that entire script in their language and then put it into production. It does not make logical sense. So for that, what we use is something which is known as API, which is known as Application Programming Interface. So what it does is you actually give out your predictions in the form of APIs, and those APIs are platform agnostic. They are just URLs that the particular person can ping in any language and get the output. And similar for us, we can also track that performance in any language. So for real-time employment, what you need to do is you need to give out an API wherein the sender will have to give you all the parameters that you require. In our case, it would be the individual details, the car details, the region details, and in return, we will give him the probability score, which he can further consume, right? So for this, what happens is that we have something in AWS which actually helps you do all of this with one click of a button, and it is known as AWS SageMaker, right? Before I go on to the AWS side of things, one person has asked me, can you tell me the main difference between the code in productionized code and Kaggle code? So as I mentioned, in Kaggle code, all of your codes generally tend to be in this linear format. By linear, what I mean is it is sequential, that over here you have your libraries, here you import your data. So what happens is if I have to change this code, I have to make a lot of manual changes. There's no modularization. And this code will only work for this particular case, that is the Kaggle's Porto Seguro prediction challenge. But say tomorrow I want to leverage this code for for another project. It will not be as simple as this. There'll have to be a lot of changes. So that is the difference. The next question is productionization followed by a custom practice across industry, or does it vary in an organization? So yes and no. The specific or the minute deployment details will vary from organization to organization, but at a broad level it essentially remains the same. As I mentioned, that if you do not want real-time predictions, in that case you just need to send out a batch prediction, and in the case you want real-time predictions, dollars to donuts, you will always have to create an API engine. Okay, so I am going to now share across the API engine with I'm going to share across a dummy API format that I had created and show you how to sort of do this deployment in a very easy fashion in AWS by a tool using AWS SageMaker. Now, similar components also exist in Azure as well as Google, but you'll have to I have only worked on AWS SageMaker, so I have a knowledge of AWS SageMaker only. So I'll be using that as the primarily tool, but you can use other cloud providers as well. They have similar services with them also. All right. So now I'm going to stop sharing my screen because I'm going to enter my Kaggle account. But I will log in as soon as I enter. Okay, guys, I have logged into AWS SageMaker. Let me know if you can see my screen. Okay, perfect. Thank you, guys. So I think you can see my screen. So now what the beauty of SageMaker is that it lets you create custom models on the fly. It also, so right now, remember we were talking about compute power, and there are so many different algorithms and hyperparameter tuning aspects that you need to go through. So how do you build all of that? So AWS has taken care of most of the things. What it does is that what you can do is you can simply create a notebook where you ingest the data. You can also sync your Git repositories in AWS so that you can directly source your projects. It also gives you the option of training your algorithm. So let's say, for example, you wanted to create you wanted to do this exercise that we have been doing, but you wanted to do parameter grid search. So for that, you had at around 2000 iterations that you wanted to test out, right? So what AWS gives you over here is it gives you the capability where you just need to submit your job. So over here you have to specify the algorithm. Like for example, they have a bunch of algorithms, but you can also use your own algorithm. And after, so you have XGBoost over here, and then over here you have the metrics that you want to choose where you want to use. You can use RMSE, AME, log loss, and then you can also input mode. You can also specify the training file, or you can also specify the various combinations. And what it does is for each iteration, it will automatically create a server, run that iteration, and then stop it. So you will not have to pay, 1 day time. You will not have to wait a day's time for your computation to run. Your computation will get over in a matter of an hour, even if you have 1,000, 10,000, 20,000, or 30,000 different iterations that you want to run. After you have run an iteration and after you have selected a model, you can simply wrap an API around it. Here you have is something which is known as create an endpoint configuration. So as soon as you create an endpoint configuration, what it will do is it will wrap an API around it, and I'm going to show you that API in some time right now. And that API will directly be used to create real-time predictions. And if you do not want to go for real-time predictions, you can always opt for batch predictions. All of this can be done at a click of a button, and you will not have to do any sort of analysis or any sort of production aspect. AWS aspect is not free of cost, but a lot of its services can be used in the free tier usage. If you do not like AWS, or if you are happy with Google Cloud Platform, you can also use their Auto ML feature, which essentially does the same thing. Okay. Now let me show you how an API looks like. Again, let me log into a secure website. So I'm going to stop sharing my screen for a couple of minutes. Okay, guys, I have logged into my system. So uh, let me know if you guys can again see my screen. Okay, perfect. So this is what is known as a Postman. It is used for pinging and calling APIs. So what I have done is I have created an API known as this URL. And in this URL, if I pass this JSON, I assume everyone understands what is JSON. If not, this is essentially how you pass data in a what we say uh, in a simplified format. So this is an API that I've created for one of the projects that I have for my current company that is live. So you can see over here what are the input features I'm passing. Fortunately, this is again a API that I created for an insurance client where I'm trying to predict the price and I'm trying to tell the client what is the percentage increment or decrement in price that the client should get. So what the website sends, and for that I'll also show you the website. So I have to fill in these specifications. What is the type of cover? What is the destination, trip date, group type, traveler's age, promotion, etc. And the website throws me these variables. What was the policy type he selected? What was the group type? What is the duration? What is the start date, end date? Which is the area he's going to? What is the discount? What is the website? What is the price code? And as soon as I ping this, I'm sorry, my bad. I guess. Okay, I think someone has shut it off. Just give me a second, please. Ah, yeah. So you can see over here, this was what was sent across, and see what was the output. I have given them the output that you have to increase the price of that particular person by 8%. So in our case, we're going to do the similar thing. What we're going to do is we are going to they are going to send us all of the metadata. From the metadata, I'm going to run it into my model, and my model is going to spit out a prediction. What is the probability that the person is going to convert? And in this case, at the back end, say if I change my model, say if I change my database, say if I change my transformation function, the production system does not need to know, because all it has to do is give me this and ping this service, and I will always respond in the same manner. So this is the concept of API, and it is very powerful. You can go into the details where you have a get API, where you have a post API, but I will leave it to you to sort of go and research about what exactly are APIs. But this is one of the ways in which you can productionize, and this is known as an endpoint. And if you go back to AWS, what it does is it creates this endpoint automatically for you. Hope this makes sense. Similarly, you can go for a batch transformation, which automatically has an emailing functionality, which will automatically in a CSV email out the results to a particular product. So this is how it is so much easier to integrate your data science model with any system without any IT person actually going back and doing changes in your system. So think about it. There is no IT person needed. What you need is just for you to give them this URL. Sorry, let me go back. What they need is just for you to give this URL. They will ping this URL they will send this URL along with this JSON, and you will give them this response back. They do not need to know at the back end what is happening, how is it happening. So we can do our changes, we can do our manipulations, we can actually integrate our entire system on itself without them having any interaction. For people who are into data engineering, this is also something which is known as a microservice architecture. So I would suggest you guys to go back and read about it and see how this is heading, because as a data scientist, this is something that you should definitely be aware of. And I think that was it from my end in terms of what I wanted to show you guys. And I think similarly we have 15 minutes left in the session, so I think I'll be fielding questions for the remainder of the time. So if you have anything, please shoot. Yes, Sandeep Shaw said, is this JSON running on AWS? Yes, this JSON is being pinged to AWS. AWS is returning a response. Want to use SageMaker. AWS also has its own API creation functionality, which is known as API Gateway. Now, this is my computer account, so I cannot obviously go into details, but give it a second. So here you can see that these are the different APIs that have been created, and these are the URL that AWS automatically creates. I just need to ping these URLs with the relevant JSON files and it should work, right? Next question. What is the model equation? So here is the best part is I don't need to know the model equation. I just need to store my model. So let me go back. For example, here, right? Over here, what happens is I have a single model that was running, right? It is known as CLF, right? What I do is I simply store this model, CLF dot save model. It will store my model. And this API at the back end will call a Python file which will run this model, the prediction for this model in a Python script, get the output, and then share that output in the API. So how did I start my career in data science? I started off with doing a lot of Kaggle competitions. So if I go through my Kaggle hub, you can see I first so these are all the competitions that I sort of tried to participate in. Oh no, these are not. Yes. So you can see my current rank is this much. These are the competitions that I sort of participated in. I have left Kaggle for a long time now because of the paucity of time. But let me just go into some of these. Yeah. So I started with cats versus dogs. Then I went on to the toxicity classification, and then I also did Portesigo. I also did a couple of other projects where I did not make any submissions. So my point is try to do as much Kaggle as you can, because of the fact is that as soon as you get into the Kaggle, you have these host of notebooks where you can clearly see what is going on. So people add these notebooks so you can clearly see what people are doing, what are the new techniques they are doing, what are the new techniques they are trying, etc. And then building your GitHub profile, because GitHub profile is the best way for you to show recruiters what you have done. Let me open my GitHub profile, please. GitHub. Yeah. So here you can see I have different repositories where I've tried to do some sessions, tutorials. This is a cab unavailability I did in RAR. This is roadside prediction. So Porto Seguro, cats versus dogs, where I sort of, I did the deep learning model. So I would say these are a couple of things that you need to do. Start learning Medium blogs, start attending webinars, meetups. Just get a toe into this field. Once you get a toe into this field, then you can clearly, make your own way as you keep on going forward. Guys, any other questions? Okay, guys, can you suggest some good Kaggle problems? Okay, so some good Kaggle problems that I would say would be definitely attempt this Porto Seguro. I really enjoyed it. I would suggest that if you are novice, you can start with the playground problems, because you will get a lot of ways in which you can solve this particular problem. So when you go into competitions, in the competitions at the bottom, you have something which is known as playground. So here. So you have predict future sales, you have Kannada MNSIT,
binary classification of cat and dog, that which I did, Titanic, machine learning from disaster. So I would say try to attempt these problems first, because you will get a lot of ways and you will understand how Kaggle works and how you need to solve these particular problems. Then you can move ahead. I actually, okay, can you share most frequently class questions about? So technically, no one will say or ask you any sort of questions regarding EDA per se, to be honest. What they'll ask you is that what are the metrics that you generally use? What are the sort of profiles that you generally use? They'll ask you random questions, but you will never be targeted any specific EDA related questions. They might ask you the libraries that you've used in Python, or if you wanted to see this sort of an anomaly, which particular graph would you use? Some basics. I have absolute error of 15K for sales price, where mean is 200K. Is See, at the end of the day, it all depends upon, right? So if you look at it, 200K is the USD and your absolute error is 15,000. So look at it in percentage terms, right? It is less than 10%. So I would say it is a decent prediction. If you can get it to anywhere down to less than 3%, that is in between the value of 6K, then I would say it would be a super prediction. Kaggle submission is platform agnostic. So what they ask you to do is they only ask you to submit the predictions. They do not ask you to submit the code. The code is only submitted after the competition is finished and you are in the money. That is, if you are actually on the top 3 podium finishers. Then they want your code to verify whether if you did not cheat on your code or not. Otherwise, you do not need to submit your code.
Any further questions, guys?
I have used deep learning in terms of it's always so I'll tell you, deep learning is at the moment a really good algorithm, but deep learning is specifically right now used in only a particular subset of use cases. So anything involving audio, text, image, and time series is generally where deep learning is being used. In time series, it is generally used when you have a large amount of data. So anywhere where you have audio, video, and text, I would recommend to go the deep learning route. Otherwise, I think the current solutions that we have, that is GBM, XGBoost, and logistic regression, are the way to go forward.
Guys, you'll get the recorded sessions, the link for the recorded session via email from us by Monday or Tuesday.
Now, this is actually a very complex problem. I would say if you're doing NLP, start off with Word2Vec, then go on to Doc2Vec, and then now with that, you can also use LSTM, sequence to sequence models. You will have to definitely, for NLP, you will have to learn deep learning and NLP based deep learning specifically. So I would recommend please understand what deep learning essentially is, and then you can approach NLP. And in NLP specifically, what do you mean by word to vectors? If I would say my suggestion for people who just starting in learning sessions, do not first of all get overwhelmed. Two things you need to get strong is A, your programming skills, and B, your basics. Be crystal clear on what is decision tree, what is linear regression, what is logistic regression. And then when you are very crystal clear with the basics, you will find that learning these advanced concept is not that difficult. As in when you keep on growing, you can clearly, see how to uplift, when to apply what. And always it is remember, data science is not procedural, it is artistic. So the way I have attempted to solve this problem, you might attempt it differently and you may be actually better, and I may not agree with you. So that is why in data science it is very necessary that you need to keep an open mind. Okay, I think the last question, there's a couple of more questions. Can you please ask Puneet how to balance the target proportions? As I said, there are a couple of methods. One is you can use smart, you can use uplifting. Another is that in the algorithm in the algorithm itself, that is XGBoost and LightGBM, you can specify the weightage that you want to give. So if you automatically increase the weightage of the minority class vis-a-vis the target class, the algorithm itself has the capability to handle imbalance. So again, if you want to manually do it, you can do it by using smart or manual uplifting, or you can actually use something which is known as class weights, which I actually have used. If you go into my parameters, just give me 1 second to see. So, okay, I have not used it here, but there is an option known as class weight. So if you use that option, yeah, over here you can see is unbalance is equal to true. If you do this true, it will automatically try to balance out the categories. Uh, full time, I would say that, remote jobs are not really available in India because I don't, because of mostly the clientele is out of India and they do not like sharing the data across unless it's a secured environment. Outside of India, there are a lot of contractual jobs you can do work from home, but in India, I'm afraid I have not seen that many work from home jobs. Yes, there are. There is Hacker Earth. There are a lot of. You can just Google online. There is Hacker Earth. There is Hacker Rank. A lot of them do these hackathons. Actually, I would not be able to answer the question AI ML because if you look at it, AI is a very broad thing. AI encompasses everything, right from driverless cars to fraud detection systems to speech recognition. Everything is AI. In AI, there is a very small subset of how you can create AI, which is by using machine learning. So in effect, you can never know entire AI. AI is too broad and too deep for anyone to understand. So think about this. AI is the bigger box, or look at it in a Venn diagram. The bigger circle is AI. In the AI, there is a small circle inside AI, which is ML. Inside ML, there are these small circles, which is deep learning, uh, linear regression, logistic regression, GBM, XGBoost. So AI is a very broad term. So I would say it is better if you learn AI, but it is too broad for any one person to learn. I would say there is no minimum experience as of now. It's just you need to show the talent, you need to be aggressive. Another recommendation I would have, we don't look at the money when you are trying to get into the field. The money will multiply more faster than you can actually spend, is my suggestion. But initially you will have to struggle because not everyone is going to let you into this field. But as soon as you get into this field, there's a lot of growth, a lot of scope. I have seen people with 8 years of experience transition into this field. I have seen people with just 6 months of experience transition into this field. As of now, there is more demand than supply, but that picture might change in the next 1 or 2 years. So if you can get in now and hope for the best, because once you get in now, I can guarantee you that the progress is in an upward fashion. Yes, I do use big data. I do use a lot of PySpark, Python in my data. So generally data science and big data go hand in hand. But big data is not necessary to know data science, because big data is specifically only for companies which are gathering big data like telecom, insurance, marketing, FMCGs. But majority of the companies do not have big data, so even traditional data science applies there.
I think let's take this as the last question, Puneet.
Okay.
Thanks, guys. If there are any further questions, please email them to us at info@edvancer.in, and we'll definitely forward them to Puneet and get his responses on that. Thanks a lot, Puneet, for this wonderful session, a very insightful and enlightening workshop, I would say, for all the people who are attending. And I'm sure they have gone back, they're going back with a lot of, thoughts and a lot of knowledge on how to further proceed with such kinds of problems and projects. So thanks a lot, everyone, for attending this session also. As far as the recording is concerned, we'll send that across on email in a couple of days' time. Thank you.
Thank you guys. Thank you so much. Bye.
Thank you, Puneet.